Hi, my dear intermediate students, MPC, BPC, CBSE students, IIT-JEE aspirants, and NEET aspirants. This is Mr. BHANU MOORTHY, Senior Physics Faculty in Hyderabad, Vanasthalipura, conducting online classes, offline classes in the morning hours and in the evening hours. Every time I am telling these points, I have to tell because this is coaching center. So short-term coaching, long-term coaching is there. Now in this video class, let us move to capacitors. We are going to discuss some beautiful concepts which are useful for entrance examinations. Some of the models I am giving to you. Model number 1. 5 capacitors are given to you. It's a commonly used capacitor figure it is. Frequently they are asking the questions from this model. That's why I have given the preference to this model. So 5 capacitors are connected, C1, C2, C3, C4, C5, between the two terminals P and Q. Now, whatever the values it may be, C1, C2, C3, C4, C5 values, as shown in the figure, they are connected. Now, what is the effective capacity between two terminals? Now C1, C2 charge is started from here. It is traveling and going to C1 and C2. So C1, C2 are in series. Its equivalent circuit I drawn here. Okay, and the charge at the same time is traveling through this C3 and passing through C4 and reaching Q. So C4 and C3 are connected in series. So this terminal is A, this terminal is B. So this is A, I written here, this is B. At these two terminals, potentials are equal. If all capacitors are identical, the potentials will be equated here between A and B. Condition applied. All capacitors are identical, C like that. Then potentials at A and B are equal. Then no charge flows. Generally charge flows from high potential to low potential, you know. But here potentials are equal. That's why charge does not go through C5 capacitor. So what we have to do? C5 is ineffective because no charge is passing through that. So C5 is ineffective. Then effective capacity, these two are in series. Then C1, C2 by C1 plus C2 formula. These two are in series, C3, C4 by C3 plus C4. Now these two are connected in parallel. So this one plus this one. So my dear students, this is the method. It looks like a Wheatstone bridge in current electricity. 5 resistances will be there. Here 5 capacitors are there. So almost looking like that. Now let us quickly move to model number 2. Now 2 capacitors are connected in parallel here. C1 is 2 microfarad, C2 is 4 microfarad. Given here like this. Okay, they are connected to a battery. The combination is connected to a battery, parallel combination it is. So it is also very important model. So there is a possibility of asking this question also in entrance examination, both NEET as well as IIT. So parallel combination, battery voltage is V, total charge flowing in the circuit is Q. Question is, how much charge is flowing through 2 microfarad capacitor and 4 microfarad capacitor? So we have to find out individual charges passing through this one and this one. So they may ask either Q1 or Q2, whatever it may be. What is the clue here? So since they are in parallel, potentials are equal. This is the clue. Potential of this capacitor is Q1 by C1. Okay. Potential of this capacitor, potential difference between these two terminals of a capacitor is Q2 by C2. Q2 by C2. So we are equating the potentials now. And potential, total potential in entire circuit, total potential difference in entire circuit is total charge divided by total capacity. So total charge by total capacity. In parallel combination, effective capacity is C1 plus C2. You know that. So then, if you want Q1 formula, then you equate first and last. You will get this. If you want Q2 formula, equate these two. You will get Q2. Finally, my dear students, CBSE, MPC, BPC students, refer these two equations in parallel combination. Q1 equals to Q into C1 by C1 plus C2. Q2 equals to Q into C2 by C1 plus C2. So, sir, actually, how to find out Q value, sir? Somebody may ask. So, I am writing Q value here. Q equals to C effective into voltage. Voltage, if it is given to you, you can calculate. So, C1 plus C2 combination, values are given 2 plus 4, 6. Into voltage, for example, is given as 5 volts. Then you can put 5 volt here. So, using this formula, you can find out Q. You can substitute here, right? Sometimes they may ask the ratio of the charges flowing through different capacitors. So, through this one and this one, ratio of charges. Then Q1 by Q2. In such a case, capital Q will be cancelled. And denominators also will be cancelled. So, Q1 by Q2 equals to C1 by C2 you will get. So, this is the most important model in entrance point of view. Now, quickly let us move to third model. Now, model number 3, two capacitors are given to you. Identical capacitors, C and C. They are connected as shown here across a battery with the help of a switch and two terminals. Now, the switch is first connected to the terminal 1. In the second stage, it is detached from it. The switch is connected now to the first terminal and then it is detached and connected to second terminal, terminal 2. First it is connected to, switch is connected to terminal 1. After some time, it is detached from the terminal 1 and connected to terminal 2. This is the question. First that switch connected to terminal 1 and then detached and connected to terminal 2. Question is, what is the percentage loss of energy? If you do like this, detached here and connected here, so then some percentage of energy will be lost. How much percentage of energy will be lost? That is the question. What I am doing here, in step number 1, first it is connected to 1. Then see, this terminal, this is excluded from the circuit because there is no connection. Only this capacitor is connected to voltage, battery. Then what is the energy here for this circuit? U1. U1 equals to, there are two formulas, Q square by 2C you can select or half CV square you can select. Because C is there, V is there, half CV square. Otherwise, Q square by 2C, energy formula. First equation I selected. Now it is detached from this and connected to second terminal. My dear students, if it is connected to second terminal, then battery is excluded. Battery is removed, suddenly disconnected. Now the battery is disconnected because this wire is connected to this terminal now. There is no connection here. See, second time disconnected to second terminal. So there is no communication here. So battery is disconnected, we can say. My dear students, please remember this point. Whenever the battery is removed from the circuit, charge remains constant. Recognize this point. Suppose we have one cell phone. Cell phone charge is over. Now we connect it to the battery. Then charging it is gradually 10%, 20, 30, 40, 50, reached 100%. Once it is reached 100%, we can remove the cell from the battery. Okay, no? From the switch now. So, when the battery is disconnected, already it was 100% full. Once the battery is disconnected, the charge does not come down quickly. For a short while, 100 remains constant. My dear students, remember this point. Charge remains constant for some time. So here also I am selecting the same model. So after disconnecting the battery, Energy I am calculating. I am selecting first formula Q square by 2C. Here C means this circuit, C means parallel combination, C plus C, parallel combination. Okay, Q same, but effective capacity C plus C. Then it becomes Q square by 4C, second equation. Then how to find out percentage loss of energy? My dear students, you observe this one. Percentage loss of energy. U2 minus U1 by U1 into 100. U2 minus U1 by U1 into 100. So U2 minus U1 means minus Q square by 4C divided by Q square by 2C into 100. So you can get minus 50%. So energy decreases. Minus represents what? Decreases. Energy decreases by 50%. My dear students, this is also the most important problem in capacitors. Once the switch is connected to 1 and then detached from that, connected to terminal 2, what is the percentage loss of energy? This is a method. Okay, my dear students, this is my way of teaching. Okay, so you in the next video class we are going to move another topic so that the students can get awareness. For that purpose only I am releasing video classes continuously. Okay, throughout India the students are observing my classes. Okay, if they understand the concepts very well, then that is enough for me. So if you are interested to join in this institution, then you contact these numbers. Every time I am telling the same points. Okay, so reserve your seat. Morning classes, evening classes, daily 1 hour class. Reserve your seat quickly. And in the next video class, let us move to another topic very quickly, very soon. Okay, see you. Bye. Then till then, if you are interested, please like, share, and subscribe. Do viral these videos to all your community system. So students community and parents community. Bye. See you till then.